remember being in class when I was your age, and I considered that kind of problem. You've always been told that if the polynomial is to degree 4, it has how many solutions? It has 4 solutions. Yet when you solve this, you would say that x fourth is equal to negative 16, and you're not so sure about that fourth root, so let's just take it one step at a time. I'm going to square root it to reduce it down to this. X squared is equal to plus or minus, what's the square root of negative 16? 4i. And so I began to ask that question. I would say, well, I know that there's supposed to be 4 solutions to this, and I know that imaginary numbers exist. But I also know that we've never talked about this. So what does that look like? For example, if I ask you right now, what do you multiply by itself to get I? I times I is negative 1. What do you multiply by itself to get I? 1 times negative 1. You got to multiply something by itself. Okay. This square root of I, which is what? You know, and so that's kind of in essence the introduction to today's piece. And so I want you to understand that it truly is a genuine question. It's something that I have asked, and to have confidence in mathematics that we have answers to these pieces are very important. And so today we answer this type of question. Finding the nth root of complex numbers. So if you had a plus bi raised to the 1 over n, we're trying to figure out what would that be. Or as an example, suppose I wanted to know the square root of 1 minus I roots of 2. Or suppose I wanted to know 3 minus I roots of 4 to the 1/5 power. I roots of 4, I should have written that. It's obviously 2. But. So anyway, here's what we do. The root is referred to as w sub k, and it is equal to r, 1 over n, times the quantity cosine of the quantity theta plus 2 pi k over n plus I sine of theta plus 2 pi k over n. Where k is equal to 1, oh, I'm sorry, k is equal to 0, 1, 2, 3, and minus 1. Yes. Yep. You're going to want to write this down. Yep. So, what does this mean? First of all, it means this. If you have a square root, you will have 2 solutions. If you have a cubed root, you will have 3 solutions. If you have the 6th root, you will have 6 solutions. Okay? n refers to the root number. So let's say you're looking for the cubed root. That'll be the 1 over 3 power, correct? 1 over 3 power. All right? So then we use n in order to choose k. If you're looking for the square root, what would n be? 2. You would then take the 2 and plug it in here. What's 2 minus 1? 1. So in order to find your roots, you would choose 0 and 1. You would choose the first 2 available pieces. Try one more, and then we'll do an example, and you're really good at that. Let's say I'm trying to find the 6th root. I would have r to the 1 over 6. So n is 6. So I'm going to have 6 roots that I find. What's 6 minus 1? So I will choose 0, 1, 2, 3, 4, 5. That's what I choose k to be in order to get my solutions. Yep, we won't do a 6th root problem, but that's what you would have to do. Yeah. So, yes. So, it says find the third roots of negative 27i. Here we go. If I'm looking for the third roots, what is n? 3. Therefore, k will be, what is 3 minus 1? So what numbers do I choose for k? 0, 1, and 2. See how I have 3 numbers that I'm using? That corresponds with 3. See how the n and the k now go together? All right. First thing that we have to do is take negative 27i and convert it into trigonometric form. Because I ask you right now, what do you multiply by itself 3 times in order to get negative 27i? I would challenge any of you to come up with them. Okay, so let's put it in a trigonometric form. 3i would be 1, wouldn't it? I mean, 3i times 3i is negative 9, times 3i is negative 27i. But what about the other 2? So here's what we do. This is 0 minus 27i. I first must find r. So I take a squared plus b squared. What's a squared? 0 plus 27 squared. Obviously, what will that be? 27. When you square 27, then take the square root. Obviously, it's 27. Right? Tangent of theta is equal to b. What is b? Divided by a. What's negative 27 divided by 0? Undefined. Where is tangent undefined? Ooh, we don't know. We don't know. We don't know. It's negative in 2 and 4. Undefined on the y-axis. 90 and 270. Which one am I referring to? 270 because that's where it's located. So my angle is 270 or 3 pi divided by 2. So my point was made yesterday, I hope, that if you don't know how to place things in trigonometric form, then this lesson will be extremely difficult, which is why we practiced that yesterday. So there is trigonometric form of the complex number negative 27i. We're still on our quest to find out what do we multiply by itself 3 times in order to get negative 27i. In order to do that, we have to use our formula for nth roots of complex numbers, and we start with w sub 0. Stands for a root. That's one of the roots. So if you write w sub 2, I'm like, oh, that was the third root that they found. So w sub 0 is, we take r, which is, and we raise it to the 1 over n power. 1 over 3 power times the cosine of theta, 3 pi over 2, plus 2 times pi times, what's k? K is 0. Divided by n. N is 3. Now, I write the same thing next to sine as I did to cosine, correct? Well, what I like to do is I like to take an opportunity to simplify things a little bit. What's 2 pi times 0? 0. Okay. So at least we can look at this. 3 pi over 2 over 3. Okay, so we need to figure out what this is. I've told you for the previous stuff, like de Moivre's theorem, I'll allow you to just leave it in complex form. Or in, I'm sorry, in trigonometric form. For these, you need to bring it down to a complex number. And I will show you how to do that. It's really not very bad at all. What's 27 to the 1/3 power? 3. Okay, so this is 3 pi over 2 over 3. What is 3 pi over 2 over 3? Multiply by the reciprocal. Yep, 3 pi over 6 or pi over 2, right? Multiply by the reciprocal. We multiply by 1 over 3. The 3's will cancel, leaving you with pi over 2. If you have exact values for sine and cosine, you must use them. If you don't have exact values for sine and cosine, you just plug them into your calculator and come up with decimal values. Is there an exact value for the cosine of pi over 2? What is it? Is there an exact value for sine of pi over 2? 1. 1 times I is I. Solution number 1. There's this wonderful thing called scratch paper. So just add more scratch paper. Good. W sub 1. The first part is r to the 1 over n. Does that change? No, so it's just going to continue to be 3 times the cosine of my angle, 3 pi over 2, plus 2 times pi times, what is the k value now? 1. Divided by 3. Plus I sine of 3 pi over 2 plus, let's save ourselves some work here, folks. 2 pi written with common denominators would be 4 pi over 2, correct? So 3 pi over 2 plus 4 pi over 2 is? So a lot of times I do that work there so I can save some room. What is 7 pi over 2 divided by 3 over 1? 7 pi over 6. Is there an exact value for cosine and sine of 7 pi over 6? Yes. What is the cosine of 7 pi over 6? 7 pi over 6 is 210. It'll be negative root of 3 over 2. Is there sine of 7 pi over 6 will be negative 1/2 times I. Distribute my 3, and I get negative 3 roots of 3 over 2 minus 3 over 2I. So I've written it in standard form where this is A and this is B. A plus BI. Oh, sure. The radius, right here. So we choose W sub 0, W sub 1, W sub 2. The 3 just came from this part right here. It's always 27 to the 1/3 for this problem, so you always have 3 up front. So what is my final choice? W sub 2. Again, we start with 27 to the 1/3 power, which is 3 times cosine of, what's theta? 3 pi over 2 plus 2 times pi times, what is my k value now? 2. Divided by 3 plus pi sine of, well, I'll figure this out now. What's 2 pi times 2? 4 pi. Write it so that 2 is a denominator. 8 pi over 2, right? 3 pi over 2 plus 8 pi over 2. 11 pi over 2. Whoop, over 3. 3 times the cosine of, what is 11 pi over 2 over 3? 11 pi over 6. Plus pi sine of 11 pi over 6. Is there an exact value for cosine and sine of 11 pi over 6? Yes, cosine of 11 pi over 6 is the root of 3 over 2, and for sine it's negative 1/2. So we get 3 roots of 3 over 2 minus 3 over 2. Similar to the last one, isn't it? What do you think? Devin, confidence. What do you think, EJ? What do you think about Devin? You think this problem on the test, say I score it out of 4, what do you think you get? Ooh, wow. Okay. All right. Somewhere there's a back side of your notes. That might be a good place to start. Otherwise, you want to take a scratch sheet of paper. We will do one more problem. For our second example, we are going to find the square roots of 2 minus 2i roots of 3. First, tell me, why is this a little bit easier? Because it's just a square root, so you're just going to have 2. Second of all, why is it a little bit more difficult? Yeah, it's a binomial as opposed to a monomial. So it has a real part and an imaginary part. Okay, so that's the challenge that we face. But fortunately, we are excellent mathematicians and not afraid of any of this. What is n in this problem? 2. What is k then? 0 and 1. So as you can see, I have 2 entries for k. That matches with the number of roots I'm looking for. Convert it to trigonometric form. R is equal to the square root of a squared plus b squared. Two squared, 4 plus 12 square root of 16 is 4. Tangent of theta is equal to b divided by a. What is b? For 2 or negative root of 3. Because, again, the formula says what is b. And this is not b. Just this is b. So we leave the I alone. Okay. All right. Where is tangent negative? Which quadrants? 2 and 4. Tangent inverse the root of 3, and you get 60 degrees. Is this the second quadrant or the fourth quadrant? Fourth quadrant is where it's located because it's over 2 and down 2 roots of 3. So it's 300 degrees converted to radians, 5 pi over 3. Very good. Theta is 5 pi over 3. So I begin by writing down the trigonometric form of the complex number, which is 4 times the cosine of 5 pi over 3 plus I sine of 5 pi over 3. This is all just work for preparation to actually be able to now use the formula. So now we use W sub 0. What's the first part look like? 4 to the, you're right, Fran, 4 to the 1/2 times the cosine of 5 pi over 3 plus 2 times pi times 0 all over 2 plus I sine of, let's simplify this, what's 2 times pi times 0? 0, so I just have that 5 pi over 3. It's 5 pi over 3 divided by 2. Four to the 1/2. Is there an exact value of cosine of 5 pi over 6? Cosine of 5 pi over 6 is negative root of 3 over 2. Sine of 5 pi over 6, 1/2. I distribute my 2, and the denominators cancel, don't they? Square root, so I just have one more. Now I choose W sub 1. Or the 1/2, which is 2 cosine of 5 pi over 3 plus 2 times pi times 1. What's 2 times pi times 1? 2 pi over 2. Two pi written as thirds is 6 pi over 3. Very common mistake at that point for people to write 4 pi over 2 or something else because you're used to doing it from previous problems. Please make sure that you write 6 pi over 3. What do you get? 11 pi over 3 divided by 2, 11 pi over 6. So I have 2 times the cosine of 11 pi over 6 plus I sine of 11 pi over 6. Is there an exact value for cosine of 11 pi over 6? Root of 3 over 2. Is there an exact value for sine? You can see that the 2's cancel. We get the root of 3 minus I. So at the beginning of college algebra, I could have said, hey, we're going to solve for x to the third. And you wouldn't have been all that impressed because it's something that you've done before, done something like it so you could anticipate. But again, just think about the question we started with. Do you know what you take and multiply it by itself in order to get 2 minus 2i roots of 3? You just answered that question. And every time I do it, I have to see it the end. I have to do it because it's like, really? We just did that? Root of 3 times root of 3? 3. Root of 3 times negative I. And negative I times root of 3 would be negative 2i roots of 3. Negative I times negative I is positive I squared. What's positive I squared? Negative 1. 3 and negative 1. I mean, you just did that. You should be proud of yourself. You're 100% correct. Is there a more intuitive way to figure this out than going through the process? There can be. You got to be really, 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 really good at your mathematics in order to get that. 4 problems. For those of you here tomorrow, you can have time in class tomorrow to work on it. raise your hand if you were gone tomorrow to Big Nine Music. So, which is why we'll be having a work day. Those of you who are gone to Big Nine Music, if you leave this to Monday, we're going on to vectors on Monday. Brand new material. So make sure that you start working on it as soon as possible. Actually, you guys got 15 minutes. That's a pretty good deal.